Hello everybody, my name is Craig Bennett and I am the founder and owner of Tech Reviews and Help.
And I'm AI.
And today we are going to be talking about gravity wells, the theory behind gravity, and how gravity affects time, how gravity affects orbits, and several other things. But before we get into this, I wanted to mention what we're going to talk about today is very important to understanding in-body problems and Lagrange points, or known as Lagrange points, depends on how you pronounce that. Now, before I get even further, because we're going to get into some stuff in the future and future videos in this one, if I mispronounce anything, then forgive me ahead of time. I'm doing the best I can as far as pronouncing it, but there's that. But as far as things, I would try to make a Lagrange point video as far as the next video, but unfortunately I can't show you the in-body problems in KSP, or known as Kerbal Space Program, the game that I'm showing you most everything, since it's quite relevant to what we're talking about. So it may be a while before I get into this, and I'm thinking about making a video both on planetary wobble effects and the in-body problems in the same video. So it'll be a little ways out, but that is in mind. So as far as this goes, I am mostly pressed for a little bit of time, so I'm going to have the AI pretty much talk about most of this stuff. And the reason why I'm pressed for time is I'm the only one that does the script, the research, the editing, and every last thing, all the way up to the start, to the idea, to the upload. So everything in between, that's all me. So anyways, as far as things goes, let's get into what is gravity.
Gravity is a force that attracts a body toward a point in space. This point in space tends to be any other physical body having a larger mass. However, this is not always the case. It's commonly thought of the middle of a black hole to have no mass. Unfortunately, there is no way to see if there isn't mass in the middle of a black hole at this time. Because of this, there is no way to finding out if you need a large mass for gravity to work.
Interesting enough, there are quite a few theories on where gravity comes from and how exactly it works. Again, gravity is one of those mysterious things, and while many people and many average Joes that it's not in the science world, in the physics and the astronomy and whatnot, the simple fact is most people thought that Newton pretty much solved it and it was dead research after that. In reality, again, pretty much everything's a theory beyond the quite obvious being terminal velocity, things drop and whatnot. But anyways, AI, please tell everybody the theories.
Yes, sir. Many scientists hypothesized that the gravitational force is mediated by a massless particle called the graviton. Another popular theory that deals with both string theory and a multi-universe theory says some of our gravity is leaked in and out of our universe. Another popular theory deals with dark matter. However, it's important to note that dark matter is, in other words, stuff we know that's there, but we don't know what it is. It's also important to note models of our universe, and the math shows our universe wouldn't be here without dark matter. So basically, we don't know where gravity comes from. But we know the mass may be needed or it makes gravity. We know the more dense matter is in a point in space, the more gravity goes to the object. We know gravity is one of the four fundamental forces of nature, along with electromagnetism, and the nuclear strong force and weak force. This is obvious in Earth-bound science. But not so much in space-bound science, physics, or quantum physics.
A side note I want to add before we really move on is how gravity affects time. This is also known as gravitational time. And as far as things goes, the Air Force, United States Air Force, and some other countries have done experiments on this. And basically they use 2 atomic clocks in one plane. Basically they put one clock on a plane, and for those who don't know what atomic clock is, please research that before you move on with understanding this theory, because it's very important for you to understand how accurate atomic clocks are. But basically they put one clock on a plane, one clock on ground. They synced them up, and they had a plane fly around for a little while. The plane landed, and they took a look at the differences between the atomic clocks, and it looks like there was nanoseconds off. Basically what was shown in the experiment is the atomic clock while it was being flying around in the plane, the atomic clock in the plane slowed down by nanoseconds. So it's very unnoticeable. So yeah, you might be able to fly around in a business and whatnot and pick on other people, say that you age less than other people who hadn't. But in all honesty, it's minute. It's almost non-existent. So that's one thing to keep in mind, that there is some difference, and that's very important, especially with certain computers and especially satellites. And I'll get into this a little bit later as far as another video. But as far as just getting into that right now, some satellites, GPS satellites and whatnot, they gotta resync the time every so often in order to make sure everything's fine and make sure the time is not that far off. And we're talking about months or years. Every few months to every few years, they resync the time. So it's nothing big. Now, let's get into gravity well.
A gravitational well is basically a quote-unquote sphere of influence. Basically, all objects in space have some sphere of influence, since it's fair to say you will get gravity if you have mass. The more mass and or gravity at a single point means you will have a bigger sphere of influence, which basically means other bodies will be affected by the gravitational forces of the first body. However, the shape of the sphere of influence changes due to the shape of the object. A planet or star that is traveling in space may have a saucer shape no matter which way you look at the object, while a cube that's traveling in space will have more of a sphere shape no matter how you look at the object. It's important to note, light bends around the sphere of influence. This was first noticed in some of the first experiments that proved gravity wells existed. Also, you can see this effect around black holes.
The biggest thing to note is it's entirely possible to use gravity wells to our advantage in space travel. And this includes KSP, believe it or not. By understanding how big the sphere of influence is and how strong the gravitational forces are, and by the way, the sphere of influences doesn't stop and begin. In KSP it does, but in the real world, the sphere of influences can actually mix, and this is very important for Lagrange points, which I'll get into for the next video. But one can easily slingshot around planets, moons, and other bodies if they know how big the influence is and how strong it is. This could, as far as if you slingshot around whatever, this could massively cut down the time and also the fuel it takes to get from one planet to another. And if you want a example on this, a real world example, look at Apollo 12, what they had to do to go around the moon, get slingshotted back, and they had to save a little bit of fuel and time. In other words, those guys would have actually died on board if they did not do that. So there's a perfect example right there. And we use that all the time when we shoot satellites to Jupiter or whatnot, and slingshot around the sun or Venus or something to shoot it out quicker and easier. It's a common practice. But anyways, as far as how important the sphere influences on Lagrange points, you have to understand where the sphere influence lies and where they mix, and then one could easily find the Lagrange points in a multi-body system. Again, I'm getting this in the next video. Very interesting and useful stuff. Not so much in KSP because there isn't Lagrange points, but still, it's very interesting stuff.
An orbit is caused when the speed of a satellite is adjusted so that it falls to the body it's orbiting at exactly the same rate that the curve of the object falls from the satellite. To put it in layman's terms, the satellite is perpetually falling, and the satellite is never managing to hit the ground. However, if you increase or decrease the speed a bit, then the satellite could hit the ground or be kicked out of its orbit. Also, on Earth, satellites must go above 200 miles, or about 321 kilometers, to avoid atmospheric interference, or better known as air resistance. However, it's good to keep in mind, there still is a microatmosphere. We lose round 90 to 100,000 tons of atmosphere every year, but mostly in the lightest components such as hydrogen and helium, about twice as much mass as we accumulate from meteoric infalling. Also, there is some microgravity, but both of these are so small. It's not really a problem, but because of this, and since Earth isn't a true sphere because of mountains, people, buildings, and so on, it's virtually impossible to ever see a true stable orbit.
Before I start the outro and whatnot, as we all know how that goes, I want to mention again that I did skip over a couple of small things in gravity and dealing with gravity, and most of this is again because I assume that you already know some of these small things. And as far as things go, some of the things do not really deal with orbital mechanics. Also, we're still today trying to figure things out about gravity. And in December 2012, a researcher team in China announced that it had produced measurements of the phase light of Earth tides during and new moons, which seem to provide that the speed of gravity is equal to the speed of light. The team findings were released in China's Science Bulletin in February 2013. So this is showing that things still today are being researched and found. It's not a dead science like a lot of people might think. In fact, it's a very active and live science, and things are found almost yearly, give or take, on exactly what it is, and then gravity. Now, as I said before, the next video is going to be on Lagrange points, so keep an eye out on that. Also, if you like, and if this video has helped you out at all, please help me out by leaving a like, subscribing, and sharing this video with anyone who you think this will help. If you have any questions, feel free to leave a comment below or leave a comment or email in techreviewsandhelp.com, and also you can leave email and YouTube, and I'll try to get back to you as quickly as possible. And I might even make a video on your question. So have a good day.